Going on, kids? Good to see ya. My hair, I'm aware, and I don't care. So, bell ringer, what's the difference between simple and compound interest? Simple interest is just calculated on the amount of money you put into your account, into that savings or certificate of deposit or any kind of money market account. Simple interest is based only, your interest is only calculated based on how much you deposited. Now, compound interest, and as Dave Ramsey says, and I'll post a link to the video in the Schoology and Google Classroom. Dave talks about how when you put your money in, so you say you're going to put $100 in the account, all right? And after a year, they give you 10% of that or $10 and they put it in there, okay? So now the $10 goes into the account. Now you own not just $100, you have $110, okay? So after a year, they give you 10% of that. But 10% of $110 is not the same thing as 10% of $100. Now instead of $10, they put $11 in there. So now not only do you have $100, you not only have $110, you have $121. So the next year, that money stays in there, and they'll give you 10% of that, and they'll give you 10% of $121, which is $12.11. So that goes in there, and now you have $133.10. And it goes on like that. That's compounding interest. So let's talk about great things, folks. Great things. Finally got a little better handle on Schoology. I'm hoping you guys will get to see a little better and understand. Taught my son how to use a chainsaw. That was a feat in itself. He has all his fingers and toes, and I have all my fingers and toes. So I consider that a success. And successes are always great things. So tell me about your successes too. Send me an email. I want to see you guys. If you want to come meet with me on the 1 o'clock tutorials, please come meet me at there. There's a link in the Schoology. I'll put it in there right on the front. Everybody from all my classes will meet at 1 p.m., but only show up if you need to for tutorials. But if you want to see your friends and your partners, hey, that's a good place you can do it at. Folks, here we go. Let's go on to the lesson. All right. So lesson objective for SAS 2, I can calculate account balances using simple and compound interest to compare and contrast both types of interest. All right. So here is the exact definition of both. But we're talking about Amanda. Amanda's analyzing how to invest $500 she has disposable to her, and she's considering two investments described below. Savings accounts are insured, and they vary in the way in which interest is calculated. Some accounts pay simple interest, but other accounts pay compound interest at varying frequencies. Amanda's considering a savings account that pays 3.75% interest compounded annually. So that's a compound interest loan or account. A certificate of deposit is an interest-bearing instrument that is similar to a savings account. It is insured and it pays interest. But unlike savings accounts, CDs have a fixed time period and usually a fixed interest rate. CDs also vary in the way the interest is calculated. Sometimes the interest is compounded, but simple interest CDs also exist. Simple interest is calculated only on the original deposit. So the CD must be held until the date of maturity, at which time the original money deposited may be withdrawn with any interest that has accrued. So Amanda's considering a CD that pays 4% simple interest, okay? Of course, I don't know about you, but you've seen how that goes. You probably know already which one to pick. So let's evaluate each investment for the first 5 years of the life of these accounts. Now, remember, the CD, it matures after 5 years. She can't touch it for 5 years. So let's see what happens. In the first year, she earns $20. 4% of $500 is $20. So at the end of the year, she has $520. She has $520, but she still only earns $20 because she earns 4% of the $500 she originally invested. So after 2 years, she has $540. After 3 years, she gets another $20, $560. 4 years, another $20, $580. Finally, after 5 years, she has $600. it looks like the difference every time is $20. That kind of takes a very specific pathway. I think we're all accustomed to what that's called. On the savings account, it's 3.75% interest. She gets $18.75. Ending balance, $518.75. And the beginning balance of year 2 is $518.75. But now we calculate the interest on that amount, that beginning balance. So the interest earned is more. It's not just the same. It's $19.45. Ending balance is $538.20. Now, you still have more money the second year in the CD than you do in the savings account. But in the third year, we are starting to earn more money in interest than we are in the CD account. Although we're still below the amount we have in the CD account. Beginning balance of the fourth year is the ending balance of the third year. We add almost $21 to it, and now we have just under exactly 68 cents less than 4-year CD. Now in the fifth year, guess what? We end up with more money by a whole dollar than the CD. So if a man is using this investment as an emergency fund, which should she invest? And explain your reasoning. Now here's the kicker. A CD, or a certificate of deposit, must remain in the account until it matures. You know what that means? If it doesn't mature for 5 years, not a good idea to use for an emergency fund, because an emergency fund needs to be able to liquidate really quickly. What does the word liquidate mean? Liquidate simply means you're actually going to take the money out of the account. You're going to turn it into cash instead of just an electronic number. And that's exactly what it is. Savings account is what she needs to choose because she can withdraw the money if necessary for an emergency. You can't do that with a certificate of deposit. All right, based on the process that you use to fill in the sheet, write a function rule to model each investment. Let Y represent the value of the investment at the end of the year and of any year X. So Y is the value and X is the year. So let's think about this. Savings account, we start with $500. And we're multiplying it by the 3.75. The decimal equivalent of 3.75 is 0.0375. We're adding that to what's already there, the 1 times 500. And then the X is the number of years. We're going to multiply by 1.0375 every year, no matter what's in the account. The CD, notice it takes a more linear move because it only adds $20 every year. So it's 500 plus 20 times the number of years. What types of function use to model each investment option, how the function is related to the type of interest earned. Savings account earns compound interest, is modeled by an exponential relationship. And like I said, the CD earns simple interest, and it's modeled by a linear function. We're going to use a graphing calculator, and I've already done this for you, and you don't have to. You might have an emulator on your computer, or you might have this calculator at home. You might even have an emulator on your phone, in which case it might do you some good. You would have to go back and add these numbers, the year as L1 and the ending balance is L2, okay? And if you wanted to, since the year is the same for the savings account, put the ending balance for the savings account in L3. That way, when you go to that account, or when you go to put it into the thing, it comes out like this. Now, these are all marked, and you've got all kinds of scalings, and you've got the axis described. But see, the savings account grows a lot faster than the CD. The CD runs in a line. But the savings account is growing quicker. It's exponential, okay? So this is the number of years. No, we only went to 5 years. So you can't really tell from here how well it is. But over the course of a lot of time, there's a lot more money in there if you just leave it in there, right? So compare and contrast the graphs of the two different functions. What do you see in terms of function rules in the tables? The data in the graph both show that the savings account increases at an increasing rate, while the CD increases at a constant rate. That's exactly the difference between exponential and a linear graph. So the function rule for the savings account is exponential, and the function rule for the CD is linear. Why is there a difference between the two models? And explain your answers using the information from the tables, graphs, or function rules. Okay, so the rate of change is different in the two functions. For the CD model, the change is constant addition from one time period to the next. In this case, $20 is added to one value to obtain the next value. In the savings account model, the change is constant multiplier from one time period to the next. Or as we called before when we did exponential functions, it's called a constant ratio. Okay, in this case, 3.75 or 0.00375. This produces an increasingly larger amount for each time the period to be considered. All right, so one of the greatest contributors to lowering the value of money is inflation, which is a percentage representing the annual increase in the value of money. Say the current rate of inflation is 4%. Now consider the investment you recommend for Amanda. Taking inflation into account, what is her actual rate of earning on the investment? Based on your findings, would you make any recommendations to Amanda? Okay, so 3.75% minus 4% is a negative 0.25%. I would recommend she find an interest rate bearing investment option that at least keeps up with inflation or makes more than inflation. At this inflation rate, Amanda is actually losing money. Now, a lot of people don't even think about that. Now, don't get me wrong, the inflation rate changes. It goes up and down. All right, I'm going to launch you with this right now. The time value of money is one of the most fundamental concepts of finance. It is based on the notion that receiving a sum of money in the future is less valuable than receiving it today. This is because a sum received today can be invested and earn interest. Now, let me give you an example of what that means. Say you won the lottery. If you're told, okay, I got a choice between a lump sum right now or I can get paid in installments over the course of 20 years. Investment people will tell you your best bet is to get it all in a lump sum. Even if it's heavily fined or heavily charged, you can probably make more money by investing that into something else than you would if you were to just take this other thing. Now, this is what happens with most people when they win the lottery. The reason why they run out of their money is because they don't invest it wisely. The best thing to do with most of your money is to take it and invest it somewhere, someplace that's going to make money. Like the stock market, kind of risky. Maybe if you invest in a particular company that you know is really sound, I would take that. I would take some money and I would put it into some risky investments because investments, the higher the risk, the higher the possible return. Of course, the higher the possible loss. But if you won the money in a lottery, if you put 10% of your money into an account and you lose all that 10%, you've lost 10% of whatever you won in the lottery. You never had it before, so you're really not losing nothing, right? So anyway, that's it for the lesson. Be sure to do the Google form assignment through Schoology. Make sure you link through Schoology to get there. And it will be due tomorrow, Thursday, not Friday, because Friday is Good Friday. So, hey, folks, be blessed and be a blessing.